All right. So do you want to go over the prep assignment?
Yeah, let's just jump right in.
Okay. Mine's up. Just let me know when you guys are ready. Oops.
All right, I am ready.
Okay. Oops. Okay.
All right, so what are we doing right now?
We're doing the prep assignment for lesson 14. Are you ready?
Mm-hmm.
Okay. According to William Butler Yeats, she is the Gaelic muse, for she gives inspiration to those she persecutes. The Gaelic poets die young, for she is restless and will not let them remain long on earth. One study designed to investigate this issue examined the age of death for writers from different cultures and genders. 3 categories of writers examined were novelists, poets, and nonfiction writers. The ages at death for female writers in these categories from North America are given in the file. You would like to determine if the mean age at death is different from any of the categories of writers. Use alpha equals 0.05 as a level of significance. So what is the research question? It's one of the 3, or which of the 3 groups of writers will die before the other ones? And state the null and alternative hypothesis. So for ANOVA, the null is that they're all equal. And then the alternative is at least one of them is different. And collect the data. I was confused, and then I watched the tutorial video where you go through, and even that guy said we don't know how he collected or how the data was collected for this. So,
Okay.
it's just there. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. I didn't do that. But we just put it into the spreadsheet, and we could pull histograms, right? And just do like the same thing that we've been doing for the other assignments and the other questions and the homework and stuff. So make inferences. What type of hypothesis test is appropriate? It's an ANOVA because we're working with 3 different means.
So it's the F distribution ANOVA test.
What?
It's the ANOVA test with the F.
Oh, yeah. Mm-hmm. In that spreadsheet.
Okay. And it's always F if we're working with 3.
Yeah. Or more.
Or more. Okay.
So the requirements for this test are that the data has to be normally distributed. And also, I think the standard deviation, there's that rule about the standard deviation being like the largest standard deviation not being larger than or greater than the smallest standard deviation times 2.
Okay.
And to check it, you go in and you do QQ plots for each data set that you're working with. And you just see if they're normally distributed.
Right.
So for this one, the requirements are met for the test. And for the test statistic, it's the F statistic for ANOVA, and I got 6.563.
Wait, so you're on number
4, D.
Okay.
Do you want to pull up the spreadsheet, or can we just talk about it? I'm doing a lot of talking. It doesn't matter to me.
I don't care either way.
However we want to do it.
You calculated the F statistic by putting it in the spreadsheet?
Yeah,
right?
you just put all the different data sets into the spreadsheet and it calculates it for you.
You just click ANOVA, all right.
Mm-hmm.
You do the first 3, and then it will give you. Gotta scroll over. F value, okay. Yeah, I don't care if you want to move on. I'm fine. I'm following.
Okay. So for degrees of freedom, I got 2 and 120.
Yeah, I got that too.
And okay. And then for the p-value, I got 0.0019. which is less than the alpha. So for G, make a decision, we'd reject the null because it's smaller than the alpha. And so for the conclusions, that means there's sufficient evidence to suggest that there's a difference in at least one of the mean ages of the writer's deaths. It's not a very well worded, but you get it. And so for take action, I thought that was confusing because we don't know how the data was pulled anyway, so I don't really feel like we can recommend something. I don't know. That one was kind of, I didn't know.
So it says, with further study, we find that the poets die earlier than the novelists and nonfiction writers. What significance can you conclude from that?
See, I feel like this.
Would that
it's like, you conclude, don't be a poet.
Yeah, don't be a poet, because crazy and die a lot. No. Does that just mean their mean was more different? The poet's mean?
Yeah.
Smaller than the other two by a significant amount? Or something?
Yeah, I guess.
Oh, but the answer sheet just says answers may vary, so it's super helpful.
Okay.
Oh, great.
All right, well, I don't think that was too bad.
Yeah, and I don't think that we're going to have to answer.
Gonna move on to the quiz.
Yes.
Yeah, sounds good.
Beautiful. Let's do this quiz, and then we'll do the collect the data or study for the test or whatever.
Let's do collect the data. Well, no, let's do the test first.
Yeah,
collect the data requires the least amount of brain cells.
Yeah, and I just realized there's still a group quiz for lesson 15. Dang.
Yeah, it's just a review like last time though, right?
Yeah.
Oh, that's what I'm counting on.
Okay. They're always at least 18, except for that one time. It was like 14 or something.
Well, maybe there will be for quiz 15.
I hope. Now for the review, there's probably gonna be like 30.
Stop! Don't say. Jinx us.
We got to give them one of everything, so we got to make it a super long quiz. Make that optional. Be like, quiz 1, 2 questions. Quiz 2, optional, 150. I don't care on there as long as it's optional. You guys have it pulled up?
Yeah, mine's up.
All right. Question 3. In an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate one mean is different from the others. True.
Yes.
Question 4. What requirements need to be checked when performing an ANOVA hypothesis test? Sample means are all positive. Believe so. Wait.
I don't know.
Yeah, it is. On the reading, it said something about that.
So, yeah, something's gotta be positive.
Something all has to be positive.
Okay.
The values of f are never negative. Okay.
Data in each group are normally distributed.
Oh, here we go. Yeah. Requirements. There's only 2. Variances are equal for each group, and data are normally distributed. So I guess it doesn't matter if it means positive or not. So it was the f that's always positive. The one I said is the only one that's wrong. Okay, question 5. To check if each group is normally distributed, do the following: the QQ plot.
Yeah, that's right.
Well, let's hop back to question 4 real quick. We're just checking the first two.
No, the second two or the last two.
Last two.
The middle one and the last one. Data are normally distributed and variances are equal in each group.
All right.
This one throws you off because it's not the sample means that are always positive, it's the F value that's always
positive.
So 6, we assume the variance in each group is the same if the following happens. Is that the third one? The largest sample mean is less than 2 times the smallest sample mean? Is that what you were just saying?
No, it's the second one. The largest variance is less than 4 times. It's different. So it's different in the text than what they tell you on like the. Do you watch the video like summaries at all for these? Yeah. So in the video summaries, he says the standard deviation, the largest standard deviation has to be less than 2 times the smallest standard deviation. But in the text, it says the largest variance is less than 4 times the smallest variance.
That's different. Standard
it's
deviation
just
variance, is it?
Yeah. Yeah. So it's the second one. We can look at it if you want.
I believe you.
Okay.
What was 5 again?
QQ.
QQ. All right. For some reason, I was hearing histogram, but that didn't seem right. All right, I'm caught up with you.
So 7, an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, and 2, 3. How many pairs are there when there are 4 samples? Okay, so 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4, so 6. Boom.
I believe you. One. Okay.
It makes sense because with 3 samples, there's 3 pairs, and then you add 1 more in, and there's 3 numbers for number 4 to pair with. So then you just add 3.
Right.
Okay, soccer shoes.
There's 5 types of shoes. Oh, 6 groups.
You guys always see me when I'm like in my slap happy mood. Sorry if I'm like
because it's late.
Weird. Oh my gosh, clothes.
Okay. I'm a little bitter that there's 6 groups.
Mine did not open.
Yeah, it takes a while.
It opened, but it's blank.
It's blank?
Yeah,
That's weird.
I thought it may be a corrupted file, and then I opened it. It's book 1, and it's blank. Oh, here we go. Now I got it. I had to do it again. Do you guys have all your variables in?
Yeah.
Yeah.
Oh man. Says, what is the minimum or smallest variance for the 6 groups? So, where do we find that on the Excel?
On the spreadsheet,
That'd be under variance, right?
under descriptive statistics.
It's just
Is
27.
it variable 3?
What?
27.208, you said?
Yeah, that's what I got for the smallest.
Yeah, I got that too.
There you go, variance. All right, yeah.
Awesome. That's what I got. Then 9. I got 53.158.
Me too.
Yep, sounds good.
The test for equal variances is satisfied for these data. Okay, I believe so because it's definitely less than 4 times.
I agree.
Not even double. So that's true, right?
Yeah.
Yeah.
11, construct a QQ plot for each of the 6 samples. Lame.
And are they normally distributed? Okay.
So where do we do the QQ plot?
In the quantitative descriptive statistics. So you're going to use both of them. Yeah.
Separate data for each one.
Yeah.
You guys want to? Should we just split it up?
And then just, run it for each of them. Yeah, let's split it up.
Each of the samples. Each of the samples. Oh, wow. Okay. So we have samples in into the cube, into the right?
So we're gonna put, or you're gonna use the quantitative descriptive statistics spreadsheet, and
Yeah,
you're
I
just
have that
gonna,
one.
yeah, make a QQ plot for each of the data sets. Or Trevor said we could split them up. I think we should split them up so it just doesn't take as much time.
I'll take variable 3.
Okay.
Number 6, since I already have it copied, all I gotta do is paste. Oh, got it.
Oh, and you've got to make sure that you sort your stuff from lowest to highest or it doesn't work. I'm doing 4 and 5.
Sort from
I'll
lowest
do-
to highest. It just does that normally.
Oh, does it? Mine didn't. I have
Mine
to
did.
go in and sort.
Never mind, you were correct. Mine did not do that.
4 looks normal. Or wait, did I say 4 and 5? Yeah, okay.
Wait, how do you...
How do you sort it? Did you get it?
Wait, how do you click sort from lowest to highest number?
So make sure all of your data is highlighted. And then go up to, there's a tab for data. So click on data. And then there should be a sort button. It says ZAAZ. There's like a little table.
Oh.
And if you click that, I think it'll automatically pull up. Mine automatically pulls up the option to sort from largest to, or smallest to largest.
Oh, wow. Okay. Awesome. Excel is amazing.
It is.
I've never worked with Excel, ever.
4 and 5 are both normal.
6 is normal.
1 and 2 are both normal.
3 is normal.
Yay! So each of the samples are approximately normal based on what you see in the QQ plot. That's true.
Oh, wait, hold on. Can I share you guys my screen on this? It looks kind of, hold on. Where do I share my screen?
I wonder if you can do it if I'm hosting.
Because one
There
of them
should
looks
be. Oh,
Screen-
sorry.
Yeah, I have that option.
You have screen
Yeah, I
share?
see it.
Okay, cool.
Oh.
I wonder. Oh, no, it should. Never mind.
All right. Do you guys see?
I see Rachel.
My face. Beautiful.
Okay, do you see it now? This?
You're not conceited at all.
Shut up. Okay. Sorry, that was mean. I didn't mean to say. Wait, Sheila. Okay.
Something now.
You see my Excel sheet?
Yeah.
Does that look normal right here
Yeah.
in the middle?
I think it looks mostly normal.
Follows the line.
Yeah, it follows a line, but like, is it normal to have that gap?
Why is there a break? 30, 31 to 36.
I guess we can just put true, and then if it's false, then we'll correct it.
That's a good point.
I agree with that.
I think it's. Trevor, I'm sorry. I told you to shut up. I'm sorry.
I promise I don't get offended very easily.
Okay, good.
I was expecting that.
Okay, question 12. If you perform an ANOVA test, you'll observe that the p-value is 0.081. Remove the SOX data and perform the test again. What's the p-value when we remove the SOX data? Okay, so
That should be variable 6.
yeah.
I got 1.309. 1.336 10 to the negative 14.
No.
Wait, what?
I didn't get that.
I got 0.309.
Yeah, that's what I got.
That's what I got
wait a
too.
minute. There's still values in for 6. I just clicked undo instead of deleting it. Okay, you got 0.309.
Yeah.
Okay, that made a huge difference. Wow. There was like 5 numbers in there. It was like 65432 or something like that. So 0.309.
Okay, so 13, the test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic?
Right.
The right. It's always the right for ANOVA.
It's always to the right.
For ANOVA.
Yeah, if you look at the reading page, there's a picture of this weird like line graph kind of thing. Kind of like the Z and the T applets that we have. You know how it does the normal curve? Well, for this one, it does a big curve to start and then it slowly goes down. And so wherever the F value lands, everything to the right is always the P value. So for this, it's always to the right. There is no left side to worry about.
Okay.
3 lessons later, we'll worry about the left side. Probably.
Okay. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file. Use this data file to answer the remaining questions. Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. Okay. Calories. Beef. So I'm just doing them in order that's on the spreadsheet. So beef, meat, and poultry, 1, 2, and 3.
Yep.
Okay.
Wait, what are we doing first? Calories?
Calories, yeah.
I wonder what meat is.
1 looks normal.
Second one doesn't look normal. I just look at them.
Let's see. Yeah, I don't think so either. I don't like that in Excel, if you delete something and you have something like copied to your clipboard, it won't let you paste it. You have to go back and recopy it. Have you noticed that?
Maybe. Not really.
Third one looks normal enough.
Yeah, there's like one outlier on the third one. There's one
It's
weird.
like the second one too.
Oh, what the heck? These didn't even order right. They just sorted this, I thought. Oh, wow. Okay, that fixed it. It was ordered perfectly except for the first one. For some reason didn't get selected.
Yeah, why did it do that? Mine did the same thing. Oh,
I had
and now
to grab onto number 1 and go all the way down. So I included 1 in it because for some reason it would move down 1 right when I click the sort button. Yeah, so number 3 looks normal. You said number 1 was normal?
1 looked normal. 2 didn't look normal. But I did it again and
So it looks a bit more normal now after doing it again.
yeah. Compared to 3, it looks more normal. I feel like it's a little subjective too, because I don't know. Never mind.
Just what's normal.
Yeah.
Depends on what you do. Yeah, 3 looks normal to me.
3 looks normal. I don't think 2 is normal.
I mean, 2 looks normal. It kind of looks the same as 3. There's that gap.
Yeah, 3 looks.
Hello? How you enterprise after? Well, I have no idea. Bye. I think 2 and 3 both look normal.
Okay. Well, we can always go back and change it. Oh, we have to look at the variances too. Compare the variances and determine if the assumptions have been met. Let's look at the variances.
The variances are fine.
Yeah, that's fine. So the first one, the assumptions have been met. It's safe to assume each group comes from a normally distributed population, and we can also assume the variances are equal. Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find the degrees of freedom are 2 and 51. Yes. That F is equal to 16.074 and that P is 0 with a level of significance equal to 0.05. What conclusion can you draw? We reject the null, so we have sufficient evidence.
So number 3? Oh, or 2. No, wait. 3. 3 or 4.
That's not really helpful.
It's either 3 or 4.
Sorry, I have to read the thing again. 3, 4. Yeah, I think it's 3.
3 it is.
Oh, wait. Have a different mean number of calories. It would be the same, wouldn't it?
What?
Because for ANOVA, the null hypothesis is that they're either all equal, or the alternative is that at least one is different.
So then it would be 4?
And 3, no, if 3 is saying all the hot dogs have a different mean number of calories, wouldn't it be 1? We have sufficient evidence to claim that all 3 hot dog types have the same mean number of calories.
Wasn't the alternative that they're different?
The alternative is that they're different. We
And
reject the. Oh, I'm sorry. Okay.
the P is so low that it definitely rejects the null.
Yeah, I'm sorry.
It has to be. So they cannot have the same mean. We definitely have sufficient evidence. So it's either 3 or 4. It's just, are they all different, or does this test? Because I thought it was only that it determined that 1 was different.
Oh, so it's 4.
I think it's 4, but I wasn't sure because it's such a small p-value. Maybe it's saying all of them. I don't know. But I think it's 4 makes the most sense.
Oh, sorry. Okay, now.
So we're going with 4.
Yeah, sodium levels.
4. Yeah.
We just wanted to read that.
Well, on 15, we're saying at least one of the hot dogs, sufficient evidence.
We the last option. We have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
Okay, so I'm doing the QQ plot for the first sodium, whatever.
Okay.
All right.
Normal.
Do the QQ plot on the second one. Normal.
Three looks normal.
Also, the variances are fine. They're not too crazy different. So this is a fine test.
So the first option. Despite the possible problem with the QQ plot for poultry, there were a couple of outliers. It looked a lot like the calories QQ plots. You decide what?
Oh, sorry.
Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine the mean sodium levels are all the same for all 3 groups. What's the p-value for this test?
I got 0.179.
Me too.
Yep.
0.179, you said?
Yeah.
You delete all the numbers in 4, 5, and 6.
Yeah, oh, yeah, that's what I did wrong. I see. No wonder. Yeah, 0.1793. Yeah.
So since it is greater than the level of significance, that means we don't have sufficient evidence to reject the claim that all three hot dog types have the same mean sodium levels, right?
So number 2.
The second one.
Agreed. I'm submitting right now.
Yeah.
All right.
We got everything right.
Yes.
All right. What's number 16 again?
Oh. Just a minute, I'll tell you.
Oh, we gave me the point even though we got it wrong, it says.
What?
Which one was the right answer?
Well, I don't know, it's weird. It gave me a check mark next to the one that you put.
Mine too.
And it on the 3 assumptions have not been met. It is not safe to assume each group comes from a normally distributed population. But we can assume the variances are equal. That one has an arrow next to it.
So it looks like they were more picky about the QQ plots, I guess, than
Oh, 2017. There's a possible problem with the QQ plot. So it's just kind of an iffy. So they just gave it whatever one you picked. As long as it was 1 or 3, you got it right.
Cool. Okay, it's done. Okay.
So now test review. You guys want to just do the quiz because the review for the exam.
Yeah, it's just the reading, right? So
yeah, that's all it is.
I vote we do the quiz.
Yeah, it's just gonna be the same things. Might as well walk through it while we do the quiz.
Oh, how many questions? 32.
Yes.
Hey guys, there's even more than 30. Wow.
You're so lucky.
Right, my laptop is like super slow now. I have like so many things up.
For some reason, the freshman dinner Excel program that we opened up last night will not close. Really irritates me. No matter how many times I push X on it, it just won't do anything. Really upsetting. I'm about to go into the task manager and make it close. You guys all have it open?
Yep.
No.
I think I listened wrong a couple times because I've got a few wrong answers on the on the quiz, so I'm going back over that real quick.
UI, I heard locked me out for some reason.
Question 2 is weird. I remember getting that wrong from one of the quizzes for the homework. I think it's number 4.
Not 2.
Yeah, because it's not we are 90% confident. But it might be because I remember this was weird and I got it wrong. But I might have put the we are 90% confident on the homework.
Hmm.
On 2 of the questions, it starts out with there is a 90% chance. And it just makes more sense, I feel like, than saying we are 90% confident. It's just that based on the confidence interval that we calculated, there's a 90% chance that the true mean heart rate is between those numbers.
Okay.
I don't know. It makes the most sense to me.
Do you need help, Alex?
No, I just wrote down all the answers, and I'll plug them in here in a minute.
Okay.
I mean, I can just tell you. I mean,
Give me just a second. I'll have group meeting quiz. And I'm open.
All right, I'm finally open now. Sorry, that took very long time.
Oh, I'm sorry, Sheila.
Oh, great. Now I have to open up 4 more files, right?
Yep. Okay. For question 2, I think I did get this one wrong as well. I wanted to say we are 90% confident, but that is not correct. Right?
Yeah, we think it's the last one. There's a 90% chance that the true mean heart rate is between 45 and 105.
Isn't there something in the reading where it said verbatim, we are 90% confident that such and such?
it might be. That might be why I thought it was weird.
Here, I'll try that one, and then we'll just see.
Well, I'm not doubting you because I know that's what I said and that's what I got wrong. I'm just condemning the reading.
All right, researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go or no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? Yes, right? The distribution of the mean of each sample is normal since the data have been determined to be normal. Distribution of the mean of each sample is normal since the Isn't that right? Or isn't it yes? Because the distribution has to be approximately normal.
I would say the first one because they're two separate groups and neither of them are large.
Yeah. That makes sense. Because it's only a group of 20 and a group of 15.
I
and
wasn't
that's
even
less
paying
than
attention.
30. So it's too small to be able to. It's too small to use the law of large numbers to make it normal.
And they've not been determined to be normal.
The confidence interval would be reliable. They create QQ plots of both random samples and see that they are approximately normal. So they are normal. So it says, yes, the distribution of the mean of each sample is normal. The data have been determined to be normal. So it's not the central limit theorem that makes it normal. It would be the first one, but because they looked at the QQ plots and they see that they're normal, I think it's 3.
Oh, okay. I see what you're saying. I kind of read that part wrong where they're like questioning whether or not to make a QQ plot.
I didn't read it. I just I kind of like blanked out in the middle of it. I just saw that.
I read it out loud and I wasn't even paying attention to it. So
yeah, you were reading it and I like blanked out halfway through. And then I had to read it like twice right here, just rereading it because again, not getting it, and then third time. All right, for all the 4 types of confidence intervals listed below, or of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Is it the third one?
Independent. I want to go with the third one.
I think so, because they don't depend on each other.
I have no idea. 3 cents. You guys both agree with it. I agree with it.
Okay.
5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains a savings account balance of 30 customers randomly. 95% confidence interval for the mean savings account balance of bank customers is found to be 3,400 to 4,100. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? Okay, if we had...
Oh, you have to increase...
Yeah, so 1.
Increase the sample size. And obtain the balances of 90 bank customers rather than 30?
Yeah, so 94.
Mm-hmm.
Or I think it is if you make it like a 90% confidence interval instead of 95, that would also do it. But it said 99%, so that actually make it smaller. Or no, larger margin of error. Yeah. So it's the 4th one, done with that.
The factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 mm. The lengths are known to follow a normal distribution whose standard deviation is 2 mm. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound, and upper bound.
Okay, so X is 1,000.
I'm really getting distracted easily.
S is 2.
Spreadsheet.
Looks like we can use the z-score here, so 1.96. N is 4. So it should be 1.96 times 2 over square root of 4. I got 1.96.
I got 1.96 too.
Is lesson 10 or 9 recap? Oh, lesson 11 recap?
What, Sheila?
Which lesson is this one from again? I don't remember.
It is, I want to say 10. Yeah, 10 is the margin of error. Let's see.
I always leave that one pulled up because there's a lot of equations on it.
It's okay, we can move on to number 7.
Margin of error.
1.96?
And to the vote.
Margin of error?
Wait, margin of error equals 2 times standard deviation over square root of n.
No, it's not 2. It's just whatever the z value is. So for 95% coverage, it's 1.96. Unless it's we're doing a T.
Oh, I found it. Okay. Okay, so 1.96. I got that too. 1.96. Okay. Input the lower bound. So it's
But you made that 1.96 for number 6?
Oh, yeah. That's what I got.
I think we need a T value for number 6.
What information would give us a T value?
So
why do we need wouldn't it be a Z value? Never mind. Why?
Well, okay, wait. So a quality engineer needs to estimate true mean length. She randomly selects 4 shafts made at the factory. So the N is 4. Finds their sample mean to be 100 millimeters. So it's not a mean, it's a sample mean. So it's S. Or no, it's whatever. It's the sample mean. So if you look, where is it?
Oh crap.
Yeah, it's a T value. If you look at number 11 or lesson 11.
Okay.
Whenever we get an S, we use the T value. Whenever we have standard deviation, we use the Z value. So because we're using S, this wait.
Wait.
Wait a minute. Maybe not.
Are we overthinking it?
I don't know.
I just think you should do 1.96. Because I don't know. Usually the quizzes are like in order of the chapters. I mean, the lessons, right?
Yeah. All right. Yeah. I just saw that it says standard deviation. Why does freaking S is for sample standard deviation, right?
Yeah, that's what it
Yeah.
said.
Okay. Yeah. Never mind. So we just take the 1,000 and subtract 1.96.
Yeah, so I got 998.04. And then for the upper bound, I got 1001.96.
You know, I did a quick Google, and it looks like you have to know your standard deviation, the funny O, for a z-score.
And then for the t-score, you have to know S. So when you're using S, you have to use the t-score, which will be different every time because it depends on the sample size.
Oh, but are we determining if this one has they follow a normal distribution standard? So is this one giving us the
It's giving us the weird shaped standard deviation.
giving us the omega? Okay.
So we were. I just thought it was all in the last unit.
Yeah. Okay.
Or the last.
0.96. Then the lower bound is 99.8.04. And the upper bound is 1001.96.
Yeah.
What was the lower bound again?
998.04.
Oh, rounding to 3 decimal places.
040. Fixer. That makes me wonder if we're doing something wrong. Are we ready for 9? To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean mu and standard deviation of 0.01 grams. How large should n be so that a 95% confidence interval for mu has a margin of error of equals 0.960.
So divide both by 1.96.
I got 38,416.
$38,416.6. So really, it should be 38,417.
What question are you guys on?
9.
Okay. We just trade places with.
How'd you get a decimal, Alex? I didn't get a decimal.
Let's see. Walk me through. So I wrote it all out. 0.0001 equals 1.96 times 0.01 over square root n. So I divide them both by 1.96, and I got 0.00004102. I then divided 0.01 by the 0.0005102. And that gave me like 196 point something, and I squared that. It gave me 38,416.61466.
The way I did it, I just got 38,416.
Yeah, me too.
How did you guys do it?
I just look at the equation. It says m equals whatever the z value is times standard deviation divided by square root n.
Right.
You can just switch m and square root n. You can just trade places to find square root n. So then you just redo the equation, and so you do 1.96 times 0.01 divided by 0.001 because that's the margin of error. And then you multiply it by itself. You square it because to get rid of the square root on the other side. So then you get n equals 38,416.
That's how I did it.
Okay. And then what happens if you plug it back in with that as the new n?
It should be fine. Last time I got it wrong doing that, not because you can't do it, it's because instead of squaring it at the end, I square rooted it at the end. That first time that we tried it when we were all confused. So I'll try it right now with 38,416.
It computes, it works.
All right, I'm just putting that in. 38,416. All right, so 10, you good to move on?
Yeah.
So 10, mean area M of the several thousand apartments in new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses are, and it should
the last one.
The first one. It's just not 1,250. Oh, wait, no.
No, less than. It's the last one, isn't it? They're smaller than advertised.
Yeah, so bottom one. Okay, in a statistical test of hypotheses, we say we reject a null hypothesis with the level of significance.
If alpha is small. Or wait, if p-value is less than alpha.
Yep.
Okay.
Okay, 12. Group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of 15 for each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their questions? Yes, right, because they're normal and the variances are fine. So,
yeah.
Yeah, so the third one.
Yeah, I think so.
Okay. Why does every question have a big long thing? 13. Medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has made a type 1 error, right? And they reject it and the null true. What lesson was that even on?
That would be lesson 9. Type 1 is reject a true null.
Okay, so it's type 1. The level of significance is made very small, thereby making the probability of committing a type 1 error very small, but have the probability of committing a type 2 error. It's number 1.
Increase, yeah.
That's right.
So when we reduce type 1, we increase type 2. So 15. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements of a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. Okay, so at a 0.05 level of significance. They advertise 1.5, and it's 1.53. That is not enough, I don't think. I think it's failed to reject the null. But we can calculate it.
Yeah.
Do we do it in the spreadsheet? Wait, how do we do this? I forgot.
We just have to get
the formula.
We just have to get the p-value. So we have to do the formula, get the z-value, then plug it in. Or is it the t-value?
Pick one.
It's a z value. Gosh dang it, what lesson was this in?
9.
I'm just going to leave that one open.
Okay.
For my z value, I got 1.765.
My z value is negative 86.7.
Your z value?
Yeah. So I did something wrong.
Dang it, I closed the normal applet because I didn't think we needed it anymore. I'm upset. How do we find that again?
The applet. You go to. Let me see if
I think there's the link at the very top of the quiz. There is.
Oh, there you go.
Oh, okay.
So then, Rachel, how did you calculate your z-score?
I use the formula here. Let me just show you what I put in Excel. This is what I put in Excel.
That's what I thought I calculated. You know what? I did it on a calculator, and I did not respect order of operations. I think I've been down this road before. Let me try this one more time.
So I got, for the P, I got 0.0388.
Me too.
Which means it is actually enough. It's irritating. Okay, so we do
1.76. 1.765.
Yep.
Yeah.
Okay.
And then they're asking if it's actually higher than advertised, so you only select the right side on the applet.
Right. And then at the 0.5 level of significance.
So your p value is 0.038.
Yes.
Okay. 0.039. And that's less than this level of significance. So you would reject.
Right.
The null.
I'm going to move again because I think my dishwasher's done.
Heat is low, reject the null.
It's after 16, we're halfway done. Trying to cheer you guys up. The 16. Sheila, are you good?
Yeah, I'm still here. My laptop is just really slow.
So you would like to look at the mean number of hours worked for races per week by students. You would like a random sample of 100 for each group. Would be consistent. What is the correct statistical procedure? That'd be a paired sample or independent sample.
Did you say independent samples to test?
Yeah, I go with independent samples t-test. Because one group doesn't take the other. So they're not paired samples. I know.
The 17. Interested in academic achievement by males with similar academic teams. She decides brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in descending order. You should use the hypothesis test based on independent or dependent sampling.
The last one, dependent sampling. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study.
Yep. Read. Ooh, this one goes to the next 4 questions. The soil scientists collected random soil samples from a field, measured the dissolved organic carbon level of each sample, recorded here. The researcher would like to construct 95% confidence interval for the mean dissolved organic carbon level of the field. Cool.
If it was an especially cold winter and there weren't enough greens for vegetables, they would eat the leaves like a bird.
So, under which tab would we do this for the quantitative inference procedure?
I only heard part of what you said, Sheila.
Which tab can we use for this one under the quantitative inference procedure?
Oh, Bill. Who's this guy again?
I didn't quite get that.
Okay. Polyparts are wave of the cell. You know what? That's myself.
Yeah, I feel I didn't hear what you said.
You will get report.
Okay. Let's just do number 18.
You know what, Toby? When the son of the Republic of Nigeria emails you directly asking for help, you help. His father ran the 3D situation, okay? All right, so raise your hand if you want to get all right. No, it's not.
We're doing a confidence interval for the mean. Deviation is from 9, right?
3 people each. The more people that get involved, the more people who are investing, the more money they'll make. It's not a pyramid scheme. It is
I guess the first one for 18. We're not comparing it.
So why, I don't understand why. I don't understand why you choose that one. Can you explain?
So we don't know the deviation of the system field. We're trying to use the sample to find the mean. Oh wait, yeah. So we don't know the deviation. We're doing the confidence interval to find the mean.
Can you guys hear my TV?
Yeah, it's the office.
I'm moving again.
That's fine. You're watching The Office right now?
Tried to get away with it. No, I'll just go back. It's too distracting. Too funny.
You guys think it's the top one or something?
I'll look at the spreadsheet. Just look at.
Yeah, I think it's the top one because we're not comparing anything. We just have one set of values. So there's no difference of means. We're just finding one mean. So it's either 1 or 3. And standard deviation is not known because it's just a random field. We haven't done research here before and calculated the standard deviation. So it has to be the top one.
I think you're right.
Okay.
So the following is the 95% confidence interval for the analysis. Okay, so let's find the margin of error. Oh wait.
I have the Office theme stuff.
Oh, this is where is this the one where we have to get to the t-value? Because we only know s. We don't know standard deviation for the whole. We just know for this sample. Right?
Yeah.
So we have to put in, so we go to the t applet, put in 0.95 for the area from the middle. And then degrees of freedom, how many samples do we have? 20. So we have 19 degrees of freedom. I got 2.093 for the t-value.
Can we put this into the spreadsheet at all? Maybe not.
Yeah, so I put you do it in the quantitative descriptive statistics.
Oh.
And then you just paste. So this is the first one that we were using.
Oh.
Mean and standard deviation and all that. But because we don't know the actual standard deviation and all we know is the sample's standard deviation, I think that we use the t-value instead of a z-value when calculating the margin of error.
Did you get 2.093 for your t-value?
Yes, I did.
And then what are the rest of my numbers? 13.193 over 4.326 divided by square root of 20.
I got 2.025. But I rounded everything to the third decimal place, so.
13. So and then the mean is 13.193, right?
About 28.5.
20?
28.5.
What did I do? For the mean?
For the standard deviation.
For the mean, I got 13.193, and for the standard deviation, I got 4.326.
Yeah, that's what I've got on the spreadsheet. I was calculating margin of error.
Oh, for the margin of error, I got 2.025.
Okay.
Okay, and how did you calculate that?
I just, so I did the t-value we found.
2.093.
By the standard deviation in the spreadsheet, which I got 4.326. And then I divided by the square root of 20.
I mixed up some formulas, so I was doing the mean over the standard deviation over the square root.
Yeah, for the margin of error, I just do the t-value times standard deviation divided by the square root then.
2.024.
Yeah, but I got 2.024.
2.025.
So I just rounded it up. For the upper bound, I got 15.217.
Me too.
And then for the lower bound, 11.168. Oh wow. Sheila's connection went out.
Uh-oh.
Yeah, she's not in the Hangouts anymore.
Oh, crap. I sent you another invite.
Okay.
All right. So we're doing 22 now, right?
Yeah.
Okay.
All right. So 22. So a random sample of Hummers for sale in LA and New York were taken from listings at cars.com. The data are recorded here. We want to know if there is a difference in mean listing prices between Hummers for sale in LA and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. So this is where we do, is this
Isn't it a confidence interval for the difference of means using independent samples then?
yeah, I think it's 2 sample t-tests. So yeah, confidence interval for difference of means using independent. Yeah. I think that's what it is. But on the spreadsheet, so it'd be 2 sample t-test one,
Okay.
I think. And then it said make sure that you make LA group 1 and New York group 2.
Okay.
We're doing a 2 sample t-test with this one, correct? Not a paired.
Yeah, it's 2 samples.
Yeah, 2 samples. And it's the price, right? Not the mileage.
No crap. Wait a minute.
No.
What did I do? Oh yeah, it's the price.
Okay.
I did copy the right one. I didn't even know that. I didn't even know there was 2 numbers. There's much less samples in
The Hummer, a popular car in LA.
So the lower bound, it already calculated that for us. It's negative 423.238.
Yeah, I got that too. Okay. 2, 8. Upper bound is 5,417.336.
Yep.
336.
Those values, Alex.
What was that?
Did you get the same values?
Just making sure I had all my I's and T's crossed. I've got T is 1.688. DF is 167.631. And the P value is 0.09325, etc. That match what you guys have?
Yeah. So
Yeah.
The next
I'm
2.
trying to figure out if it's not equal to, or is there a greater than, less than?
I think you only need the upper and lower bounds for this. So just the confidence interval.
Yeah, so the type of test is just not equal to. Is that what you're asking?
Yeah.
Because they just want to know if there's a difference.
So then with this information, we go to the T-score?
No, for the lower bound for number 23 and the upper bound for 24, it calculates it for you. That's the confidence interval. So just put in negative 423
Negative 423.
for the lower bound, and then the other number for the upper bound should be like 5,417.
Oops.
Okay, so negative 423.238, upper bound 5417.336.
Yes.
Okay.
I think the next one's an ANOVA.
So that's all we needed for that one. So now we can move on to the exercise bone density thing. So I'm just going to start downloading that now and opening it. All right. So it says many studies have suggested that there is a link between, dang it, exercise or Excel just popped up on the screen. So many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups. A control with no jumping, a low group, the jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The data are recorded in this Excel sheet. So they just want to know if the mean levels of bone density are different between the 3 groups. So this would be the F or the whatever. Yeah, the F.
ANOVA.
Yeah, the ANOVA.
Okay, for the test statistic, I got 7.978. Wait. Am I?
Your F, you got 7.978.
Yeah.
Same.
Okay.
Same.
So 7.978. Oh, I didn't even know that the ANOVA was the first question. Give the p-value. I got 0.001. So I guess 0.002.
Yeah, I rounded to 0.002.
Okay.
Looks like jumping does make a difference.
Maybe if you get out there and exercise.
Which of the following express the best conclusion? It's less than the level of significance, so I think it's the first one. Wait, maybe it's the...
Looks like my sister-in-law is going to have a baby.
Congratulations.
It's exciting. So there is sufficient evidence. that
the bone density between all the groups is different?
I think it's 4.
Or
I think this test just tells us one is different. Right?
oh, that's right.
So 4 says there's sufficient evidence to conclude that at least one of the groups is different from the mean bone density. I think that one's right.
Okay.
Are you guys cool with that one?
I think you're right. Yeah, one or more is different from the others. You're right.
Okay, and then the last one, direct flight costs. This one, they're basically just they want to measure the difference between a 90-day buying a ticket 90 days before your flight or 2 weeks before your flight and seeing which one costs.
Okay.
I read this at the beginning and downloaded it. So we're just comparing two. Would this be paired or would this be paired? Or dependent samples test?
How are they dependent though?
I don't know.
Um
This is the same flight. I don't know. It's a weird one. The prices might just be independent of each other, but both. So I think it might be dependent just because you're looking at the same flight and you're just checking the price from 90 days before the flight and 14 days before the flight.
Yeah, but the numbers themselves aren't dependent on one another.
yeah.
Samples
True.
themselves aren't dependent, even though they are related.
Okay, true. I could agree with that.
So it's independent samples. Okay.
Okay. So 2 sample P test. And then does it say which one goes first?
It looks like 14 is first and then 90 is first. It's that last sentence for the next 4 questions. Do 14 days, 90 days for the analysis. For 14 days, less 90 days.
Okay. So 14.
This is a 2 sample t-test.
Yeah. This is all like making a lot more sense.
Yeah.
Just got to figure out which one to use, and then it's like once you know what you need to get doing, it's not that bad.
Yeah.
What you have to do. Okay. Wow.
Did you guys get 88 for the first one for the 14 days out?
88 for
Your
N.
sample size, yeah.
Yeah.
Sorry.
88 for both of them.
Okay. I just want to make sure.
Yeah. U1 minus U2. So 14 days is the first one. I had to go through my notes to make sure that. Give me a second to plug in. I never did ask the professor about what we do if there are blank spaces. If you remember from our quiz yesterday, or the homework yesterday, that the presence of the blank spaces screws up your numbers.
Oh, yeah.
So do we put a 0 in? I get.
There should be 90 for n. So just remember the n is actually 90, but don't put any zeros in the blank spaces because all the other numbers will be right.
Okay.
So yeah, this spreadsheet gives us the wrong number for n.
Well, if a ticket's not available, then I guess it doesn't count for the sample. So in this case, it might not screw us up.
Well, because there's only one of them that the ticket wasn't available for either. The other ones, the ticket wasn't available on one for the 90 day, and then it was available at 14 days. And the other one was available at 90, but wasn't available at 14 days.
Fine. So n is 90, everything else we'll keep as is.
Yeah. So what do we need to, we're just trying to figure out the test statistic.
I got 0.837.
Okay, same.
0.837.
0.404.
4.
So that is definitely not sufficient evidence. For the first one?
Yes.
All right. Dang, we still gotta do the flex the data.
I'll submit. I got a B.
That means we have to go through.
Okay, timeout. Let me just start from the beginning.
So you're starting at number 1.
Yeah, I'm just gonna look through and see where.
Did we get question 2 right? Because I know we were.
Oh, you know what? Let me see what I put for that. I can't remember. For question 2, I put we are 90% confident, and that's right.
That is right?
Mm-hmm. Yeah.
Just got to remember that that is just the we are. That's weird to me.
Well, I think too. So it's asking for a confidence interval, and the other question said there's a chance. So I don't know. Maybe.
It's question 2. We are.
So, yeah, question 2. We are 90% confident.
Okay.
And then we did great until question 29. We
did great until 29?
Yeah.
Wow.
We got everything until 29. So it's a dependent samples test.
Okay.
Trevor, so you were right.
That kind of makes sense because what if 90 days before the price is so good that the tickets sell out and then you have no ticket to buy or something like there's some kind of dependence.
Crap. Okay, so that's dependent samples test. Question 30, the answer is 1.685.
Oh, we only got all these wrong because we did the wrong.
Yeah, because we chose the wrong test.
Okay, so we know how to do this still. So 1 point what?
1.685.
5.
The p-value is 0.096.
0.096.
And then for question 32, it's the second option. There is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
All right, do you want to do your second attempt?
Yeah, would you please just keep yours open? I'd appreciate it.
Okay. So sufficient evidence to conclude there is a difference?
Yeah, it was the second option.
Okay, and it was 0.096 is the p-value?
Yeah.
And 1.685 is the test statistic.
Yep.
And had we used the paired sample t-test, we would have gotten those numbers.
Yep.
Okay. And so, Trevor, you're submitting?
I already submitted. We got them all right.
Okay.
But I'm leaving it open.
Can you tell me what 3 is?
3 is yes, the distribution, and then it ends in normal.
Oh, okay, thank you.
So 3. 3 is 3. 4 is also 3. It says confidence interval for the difference of means using independent samples. 5 is the 90 bank customers. 6 is 1.96.
Okay.
7 is 998.04.
Okay.
8 is 1001.96.
Okay.
9 is 38,416.
Okay.
10 is the bottom one, the less than 1,250.
Okay.
11 is p-value is less than alpha.
All right.
12 is the third one. Yes, it is enough.
Okay.
13 committed type 1 error. 14 is the top one. By reducing committing type 1 error, we increase type 2.
Okay.
15 is reject the null, the bottom one.
Okay.
16 is the second one, independent samples t-test. 17 is the bottom one, dependent sampling. If you select brother, you must include sister.
Okay.
18 is the top one, when deviation's unknown. And then 19, 2.025.
Okay.
20 is 11.168.
Okay.
21 is 15.217.
Okay.
22 is number 3, difference of means using independent samples.
Okay.
23 is negative 423.238.
Okay.
24 is positive 5,417.336.
Okay.
25 is ANOVA.
Okay.
26 is 7.978.
Okay.
27 is 0.002.
Okay.
28 is the fourth one. There is sufficient evidence to conclude, at least one of the groups.
Okay.
29 is dependent.
Okay.
30 is 1.685.
Okay.
31 is 0.096.
Okay.
And then 32 is the second one.
Okay. Thanks so much.
I think it's just faster and easier that way.
I do too.
All right. What do you guys want to do? Do you guys have to collect the data or what?
Since that's my piece.
Well, so we're on the same page. Shouldn't take too long, right?
Yeah, I say we just do it.
All right.
We're supposed to do these together, but whatever you selected as your thing, you're just kind of in charge of making sure it's submitted and done and stuff.
Yeah.
So I'm not entirely sure what we're supposed to do. Do we literally just submit the numbers that Sheila gave us?
Would it be that easy? I feel like it won't be.
I'm wondering, is it really that easy? Last time we had a whole sheet to do.
Let's look.
Oh, here it is. Click on the directions. Okay.
Create your research question. If possible, everyone in the group should participate in gathering data.
These are always so all these questions are stupid. So what I did, I just used this sheet that they give you. Then under each question, I just made a little space, pushed tab, typed the answer, and then I bolded it so it was easy to see.
Okay.
But this might be a little different. All right, hold on. So there's only 3 questions we got to do. Then describe the data. Okay, so you go to the very bottom. Your document should include the following: the title, final project, select and describe data. Okay, so that's the title. The names of all the members in your group, your research question, 1 to 3 paragraphs summarizing and describing your data. Make sure your descriptive statistic values are stated within each paragraph. Okay, so like all the p-value and all that.
Yeah.
So all we do is put that in the quantitative.
Yeah.
Statistics.
And then, so then, well-labeled and helpful graphs of your data. I know I could do a histogram for sure, but.
And the QQ plot is on the same thing. You just switch over to the QQ plot.
Oh, okay. Yeah, I can do a QQ plot.
So we can just have both of those.
Okay.
And good. And then well-labeled and helpful. Okay, yeah. Responses to other questions in this worksheet. I don't. Is there any other questions?
I thought that was it. Okay, so I'm gonna work on this, and then I'm probably gonna message you all just to review it before I submit it. So would you guys just be available to do that? Sometimes just glance over it and.
Yeah. Do you want to so you would just have to paste it all together.
Yeah.
You just do this research question, and so 1 and 2 real quick, and you can just type underneath it. That way you can just copy and paste on your new.
Oh yeah, I'd love that.
What?
Yeah, that would be great.
All right. So our research question is: are the number of M&Ms in each fun-size pack of regular M&Ms the same or different? Question mark. I think, unless you guys think, like, I don't know.
Okay.
What do you guys think about that?
Are the number of M&Ms in each fun-size pack of regular M&Ms the same or different? I reword it. That's what we're asking. Let me think about it. I might reword it.
Instead of the same or different, we could just say are different in each pack or something like that.
Oh, different. That's better. Okay. Possible. Everyone in the group should participate in gathering data. So are we gonna get? Is it gonna be a problem that only Sheila got the?
No, we don't even have to mention it.
Okay.
We group all the data together. They just said if possible, everyone should participate.
Okay.
Just say for the short summary of what each group member learned while collecting the data, describe where and how you collected your data. So
What did she buy? She bought like a fun size pack, or not. She bought like a bag of fun size. Do I need to say that?
yeah, I don't think it matters if she's the only one that did it. So we could just explain what she did. So Sheila bought a bag of fun size packs or a bag that contained
what, 44? I can't remember what she said.
There was 40 something.
40-something.
Oh, 44 samples. So Sheila bought a bag of 44 samples of fun size regular M&M packs from the store. And she opened the pack individually and counted the number of M&Ms inside. As she did this, she discovered that every pack contained somewhere between 14 and 17 M&Ms. So that's what we discovered from it. They always had between 14 and 17.
Okay.
Was there a situation you had not anticipated?
Guess we didn't anticipate one bag having enough of those samples.
Yeah, we didn't anticipate only being able to get or there being so many fun size packs in one bag. How did you handle it? We made Sheila be the only one to collect data.
How did you handle it? Okay, well that's the gist of it, and I'll go back and put more information.
You feel confident on all of it?
Yeah, I do. I think this will be fine and quick. So I'll just I'll work on it, and then I'll email you all when it's done, and then you can just look it over.
Sweet.
Okay.
You need any help with anything?
I don't think so. I think it'll be real easy. So I'll just, yeah. I'll let you know.
Awesome.
Cool, guys.
All right. Well, good luck. Catch you guys later.
Yeah. Good luck on your tests. See you next week.
I hope that goes well.
Yeah. Me too. Bye.